Afternoon. My name is Steve Gordon. I'm currently the Secretary-Treasurer of the SIG HPC Education Chapter of ACM. And here I'm just here today to host this discussion of using HPC in the classroom. We have three participants in the panel who are going to start by sharing their issues and how they've tried to resolve them, and then we hope to
turn up volume
discussion by all those others that are participating to get your ideas and questions. So to get started, I'm going to turn it over to Mehmet. So, Mehmet, could you please introduce yourself and get started with the discussion?
Of course. Thank you, Steve, and thank you for everyone who joined in. I'm Mehmet Belgin. I'm from Georgia Tech, and I lead a team of research scientists and a customer experience team. And we started supporting instructional resources very recently. Actually, we kicked off our first cluster just last week. So we are new in this game, and then we were discussing with other campus champions and in the conferences, we noticed a couple of things. First, our problems are common, but we are trying to address them in our isolated world, so we almost never shared some of these common problems before, and so that's why I'm very happy to be here. So,
yeah, go ahead, and then when you're done, we'll introduce the other panelists.
I couldn't catch that. There's some noise in my microphone.
Okay. Mehmet, why don't you go ahead and share your experience, and then we'll introduce the other panelists in turn.
Of course. Really quickly, at Georgia Tech, first I would like to mention that there we have a shared slide, and it lists three main categories, and we're going to share our experiences around those categories, and one of them is the account management. So in our case, then we reached out to faculty. We had an overwhelming response. We estimated, depending on those responses, that we will find ourselves supporting more than 5,000 undergrads and grads throughout the lifetime of this instructional cluster. That's a lot to keep track of when it comes to account management. So compounding this problem, some of these students might be eligible for or already have accounts on the research side of things. So they just mix, overlap, and it's very difficult to manage this situation. So this challenge can be greatly mitigated by letting others control the system. And in our case, Georgia Tech has a centralized system for keeping track of class enrollments, and some of those classes which are represented as groups can be exposed as POSIX groups, Unix groups. So we just tap on that, so it's completely no hands right now. Departments have full control of account management, and when students enroll classes, they're added automatically to the cluster. Then they drop the classes, they are removed. So it's really good. Otherwise, it will be impossible to manage this in a sustainable way. So from that point of view, separation is very important of research and instruction. That's why we created this isolated instructional resources. So, of course, there is some discussion, and I'm not going to go into details. We can discuss them later in the discussions, but data management can be a problem. Garbage collection can be a problem, and I'll be happy to share my experiences around those. In the second category is the resources availability. Most of these research clusters are category is the resources availability. Most of these research clusters are funded by research, right? So they are used for that, and they are highly utilized. It's almost never a good idea to unleash an army of students on these resources and expect everything to go smoothly and efficiently. So we are trying to shield our researchers from that by this isolation. And it also gives us a little more advantage and flexibility in customizing these resources for the classes. For example, some classes, they require some specific hardware. Could be Hadoop, MapReduce, Spark, or they might need multiple GPUs in a node, or they might need high memory. Well, we can do all of these if we have dedicated hardware, but we cannot really get a research cluster and just change it just for the classes temporarily. It's going to be very it's going to interrupt the research progress, right? So another important point is sometimes you need some homogeneity. Georgia Tech has some shared resources, and we tried to support some classes in the past, but it becomes a problem because HPC education, as the name suggests, requires performance tuning and comparison, right? On a heterogeneous cluster composed of lots of old machines and new machines, you cannot really compare these projects and grade students accordingly. So having one homogeneous cluster really helps us that way. And lastly, I want to quickly touch on the training part. We are currently understaffed. We are hiring, by the way. And we cannot really have understaffed PACE teams, support the entire student community. Instead, we are training the TAs and instructors, and we have open communication channels with them. They can come to us for any kind of problems they need, and we just customize our cluster orientation for them so they can also share some of the slides with the students. So they are handling the student training. And we received a lot of demand from many departments. I'm not going to count them here, but there are more than 10. And the initial response was for more than 20 classes. And so it's really, there's a lot of demand, and that's how we estimated the 5,000 students by just considering these. And there will be more in the future. And the experience with these researchers on the instructional cluster is, well, identical. That's what we are trying to achieve here. Because most of these professors, they would like to teach what is relevant to their students, and what is relevant to them is what they're running on the research clusters, right? And by keeping these research clusters identical to instructional clusters, we provide that environment. They don't have to recompile anything because we make the entire software repository available to everyone, all of the students. So these are all good benefits. The only thing we create isolation for is the account management and data. Other than everything, the system, software, schedulers, they're all identical. So we are trying to announce this cluster in many different venues. We are working on an article, and I'm hoping to put that in new faculty orientation. So at this point, I'd like to stop and let others share their experiences, and I'll be back for answering any kind of questions that you may have.
Thank you, Mehmet. For those of you that are on, if you could please mute if you're not speaking. There's some background noise coming through, and it would be helpful to the speakers to have that. Not have that. So, who's going next? Is it Scott or is it Lynn?
I'm happy to go.
Okay, Scott, would you introduce yourself and let you go ahead?
Sure. So I'm Scott Hampton. I work for the Center for Research Computing at the University of Notre Dame. And I will just start out quickly by telling a little bit about how our site is set up. So as we were discussing sort of what we're going to talk about today, we all kind of had a lot of the same types of problems. Just a lot of it boiled down to how we handle them individually at our different sites. And so here at what we call the CRC, so we have about, in total, we have about 2,000 servers. We have varying architectures, some less than a year old, and some much older than that, 6, 7 years old. The greatest majority of those are faculty owned. They have about 90% total of our total compute power, and then the other 10% or so are what are called general access, and so anyone on our campus can have access to those. Primarily, we do so through just a very simple application process where students and staff just fill out a form and let us know who their PI or advisor is, and we affiliate their accounts with that PI. Something that we do a little bit differently probably than most is that we don't use that really for accounting per se. So there's no real limit on the number of cycles that you can use. There is a built-in priority scheduler that will allow people who have used fewer resources recently to have higher priority. But for the most part, it tends to be kind of a first come, first serve basis. And as part of that, we have let pretty much anyone on campus just use the resources that they ask for, until about 2 years ago we started seeing a real increase in the number of requests for faculty to allow us to let their students use our resources for the courses. And this started out pretty much as, sure, that sounds great, just have them request accounts, and then we would tie in those accounts to that particular professor. And then we found out over time this led to a number of issues. Primarily, each account was assigned to that course professor, and so at the end of that course, it wasn't immediately obvious that some of those students may not actually be doing research with that PI. And so then they were having issues with their own, for instance, their own storage and things like that. And then also another issue was that as this started per semester increasing the number of students, it sort of became an issue in that we were just getting individual dozens and sometimes even into the multiple dozens of account requests coming in daily. And it wasn't efficient use of our time or our application process, and so we moved to marking those particular classes. So when those requests would come in, we would mark those as a class and then assign that account. Rather than assign it to that PI, we would assign it as a course. We do not differentiate between any of our general access hardware and sort of an educational cluster, if you will. Everyone who has an account has equal rights up to and including whether or not, if they happen to be working with a particular advisor and have access to those private resources. And so that was kind of a learning process and just setting up the accounts. Another issue that came out of that was we were quickly overwhelmed with training, and we've since implemented a policy where we highly recommend to a professor, if they want to use our resources, they're happy to do so, but please let us come to your class and take half a class up to a class and sort of do that introductory session that we do with all of our new users. We had training classes twice a week, but they're meant for really small, sort of interactive, 6-7 people at a time, where we can actually get to know and to help those users in their research. And so when, like this semester, we had somewhere around 150 or so new account requests for various courses, and if we had tried to do that 6 or 7 at a time, we would still be doing that well into March. And so we try and cover that sort of introductory part well into March. And so we try and cover that sort of introductory part right at the beginning of the semester, and sort of get that out of the way. And it also helps the students too, because a lot of these students coming into these courses, it's very common that they've never used a Unix system before, and so there's that whole issue with trying to teach someone how to use Unix. And then even if they have done that, it's generally a new concept to use a machine remotely. What is a front end? What is a compute node? A scheduler? Those types of things. And so we'd rather do those in bulk to begin with, just trying to get that sort of initial learning curve out of the way, so that then we're happy to meet with them individually later on for specific problems. that they may have. One side effect that we've noticed with this, and something we're still trying to manage, is that sometimes we end up, our team ends up being a TA for a course, which is not the intent at all. We certainly don't have the staff to do that. But you know, sometimes it's the small technical details that should be handled really right by the professor, and if they don't have TAs themselves, you know, they should be kind of answering these questions. We're more of the technical support, I would say. But that's, you know, these are also parts of the learning curve. And then on a final note, one of the things that we've seen, and this was true before we started seeing an uptick in course requests, but at the end of the semester, there's always, you know, there's projects that are due. A lot of times there are deadlines for papers and things like that. And so our usage, if you track usage, it definitely peaks at about 3-4 weeks out from the end of the semester and stays that way up until finals usually. And so that's something else that we've had to kind of manage primarily by sort of lowering the number of active running jobs for everyone, unfortunately. But this is not as, for us, it's not as big of an issue with the course assistants, because a lot of times those students aren't really doing real HPC, as we would say. It's more of a just using the tools that we provide. And just as a final thought, some of the other issues which are mentioned briefly in the notes is we do see an uptick in certain programs, like we have licensed software. A lot of times those become, again, depending on the course, but those can become highly sought after. And so these are just some of the things that we're dealing with now. And so from there, I'll turn it over to Lynn.
Okay, Lynn, could you introduce yourself and talk about what's happening on your campus?
Hi, my name is Lingo. I am the Director of Data Science for the Cyber Infrastructure and Technology Integration Group at Clemson University. I come to this panel kind of playing both roles, because I have also been on the side of doing research facilitations and provide research and education support for the faculty. And I also teach a class where all of the students use the supercomputer for their assignment and projects. So I'll start by talking about the resource availability at Clemson University. We have a rather large supercomputer with about roughly 2,200 nodes. So at the present, we are still don't separate into educational or research resources. We have resource owner who have priority access on the resource, but everybody else within the university can apply for an account and can use the computing resource at the university. And so far, we have not seen usage contention between education and research. On the other hand, we are seeing the same thing that Scott observed over at Notre Dame, is that students procrastinate and they wait until the end of the semester to do things, and it mostly just students frantically send emails to IT help saying that they are waiting long in the queue and so on, and there's really nothing we can do about that. We have, particularly in the fall, we have a minor maintenance sometimes during the semester that take about 2 to 3 days, and that sometimes run into conflict with assignment deadlines and other things, and we try to overcome that by just publish and just send out frequent reminder that the system is going to be down. For the computer science and electrical engineering courses, sometimes students need access to administrative accounts, and we cannot give them that on the main supercomputer at Clemson. And we have been utilizing the National Resource Cloud Lab extensively for those type of courses. And we recommend the faculty who teach courses who, for example, want students to do performance evaluations and measurement to go to Cloud Lab or Chameleon for that type of education activity. In terms of common architecture and service requests, um, we have seen mechanical engineering, chemical engineering, and math as departments that have most of the courses that use supercomputer, and they use the same research software that they have been using. And then for computer science and bioinformatics, we see people requesting GPU and some of the Hadoop components for their courses, MapReduce, Spark, HBase, and so on. In terms of account and data retention, at Clemson, we actually share the authentication system with the main campus identity management. So the user have the account created on Palmetto, but then authenticated against the main campus authentication. So we don't really have a big issue with maintaining a lot of accounts. On the other hand, we have the issues of student accounts who were created for classes but were not monitored and managed properly, and over time after they finished the class and they never really used the supercomputer for research, we have somewhat of the ghost accounts just lingering around within home. And in some cases we have students who use this account to abuse the infrastructure. So starting from the last semester, we have divided the account into two types, research account or education account, and we maintain this separation somewhat manually based on the incoming account creation request. For the research account, we allow them to exist until the end of the student career, but for the education account, we deactivate them after one semester. So they can still log into the supercomputer, they can still see the data, they no longer can submit the jobs. And we also require any account request who is not a tenure track or a teaching faculty to have a sponsor. So someone that is going to kind of vouch for this person that they are requiring an account with for a legitimate purpose. In terms of training, the instructor who use HPC for education are also faculty who doing computational research, and most of them are very good users. But on the other hand, when they teach the courses are often focused on theoretical aspect rather than computational and practical aspect. And therefore, we see students coming in with problems, again, that are very highly theoretical in nature, but they struggle with some of the basic skills in interacting with a supercomputer. We offer monthly training courses that teach basic skills, but since these courses are often half-day intensive course, many of the students don't have the time to go to attend these courses. Some of the solutions that we try to make was to make available all of the material that we are teaching, and we share it with all of the faculty, and we tell them to just guide and direct their students here. We also attempt to just head off the curve by going to new graduate student seminar and orientation, and just tell them to go ahead, Clemson has these great resources, go ahead and learn how to use it, just so that when they actually take the course, they are ready for using the HPC. Our team also integrate a software called Jupyter Hub, and that actually helped a lot as the user are able to be shielded away from the standard command line login to the supercomputer, and a lot of them can now just use the web browser to interact with the supercomputer and use the notebook to run the computational program without having to go through the command line and learn Vim and Nano and all of that complex things. And then recently we also we realized that HPC is going to be very highly integrated across all of the disciplines. So we are beginning to collaborate with faculty and to ensure that they can start transitions and they can start integrate our workshop material into their course curriculum instead of kind of like have a somewhat of a two-track that the student have to go get a training somewhere to go back to the course. Instead, they should be picking all of that from within the courses that they have. So that's what we have at Clemson at the moment.
Well, thank you, Lynn, and thank the other panelists. I think what we'd like to do now is to open this up for discussion, either questions for the panelists, or if others have similar experiences, if you want to share that. Since there are quite a few people on, if you could use the chat option to just type in your name when you want to be recognized, and I can recognize one person at a time who wants to speak. So let's open it up now for that discussion. Well, I didn't expect no one to say anything, so give you a minute to think about it. So let me just pose a general question. So, so it seems like one of the things that you have in common is the training part. And I know you all have course materials. Have you thought about sort of online training modules or other kind of short kinds of little videos that would help students with particular questions? Is one way of dealing with that problem.
I can go first. About 2 years ago, we did try to have video training at one time, but what we actually found out is that even within the HPC environment, we are changing material and we are changing the interface fairly frequently. That making the video and trying to remake the video is it takes a lot of effort. We tried video recording our training sessions and posted it on YouTube, but with just recording a training session, the graphic is not very good. The sound is, and it's difficult to look directly at what we are typing. And then it actually takes a lot of effort, at least several hours, to just sit down and trying to go through a well-designed video training sessions. And just through the process of over a period of, I think, 1.5 years, we actually go through several different recommendations for the, for example, the terminal software for Windows user use to HPC. We go from the standard SSH client to PuTTY, and now we are recommending Mobile Xterm as the default client, and we are looking into using the Windows Linux subkernel. So things change frequently, and we don't know if a video-based training is going to be that useful as compared to a very detailed text-based training. And that's what we're trying to maintain with our GitHub repositories.
Excellent. Any of the others have anything to say about that?
I have a comment about it. As I said before, our instructional cluster is just a baby now, so we are not really aware of the demand that we will get from the researchers and students for the future. So I was naively making an assumption that the training part would be on the instructors and TAs, and there will be some course class dependency to other courses, which gives an introduction about using Linux or using, this kind of resources. So I was hoping to get away from actually this training activities to train all of the students. But now, given the comments and the focus by both Notre Dame and Clemson on this training is kind of scaring me, so I'll be more prepared for that, start thinking about it in the future, I guess.
Okay. There are a couple questions from the chat window. Well, Carl Alving asked, do you have any apps that users can run as practice that actually compute something significant, but they don't have to write, so they can practice running a job? So sort of a practice job so they can see what the structure of the job looks like and get some results. Have any of you used that kind of an approach?
I would just use an example. As I mentioned earlier, we tend to meet weekly with new users, not necessarily related to our courses, but just in general, new users in small groups. And I always try and take an example from someone who's actually attending that meeting and say, what are you doing? And we try and use just a basic example here's how you might run, say, a MATLAB job, or how you might compile a Fortran program and request maybe a couple nodes if it's based on MPI. So I would try and do short examples like that, but other than just sort of some toy hello world type things, I find that that's probably more applicable.
Okay. Another question that was posed, has anyone integrated access to the HPC resources from a learning management system?
So I'll add to Scott's answer. At Clemson, we maintain a Git repository where we have a bunch of examples. We also don't have anything that runs on a real application, but we have example of some of the common programs that people tend to run on the supercomputer, and also some of more simpler approaches in just very rapidly scaling up the performance, like how to use new parallel or how to use the job array within the supercomputer, and we have that as a repository and also as a loadable example module when they first log into the supercomputer that they can just activate and take a look at.
Okay.
I'd like to also make a comment about that because it's a question that's very relevant to what we are doing. We received a couple of requests, for example, a shared directory where the students can drop their projects or homeworks with special permissions. We couldn't really take that risk to support that, because if there's a problem with file permissions, it's a lot of responsibility and liability, and especially exposing students' projects to all of the students all of a sudden is not a good idea. So we just made it very clear that our cluster is a resource. It's not a learning management system, but it also raises this need to integrate LMS to the clusters and give the instructors and TAs as smooth workflow to use this resource efficiently in their classes, which are managed by LMSs. And there's a lot that we need to discuss with the LMS team on our in our university.
Yeah, I help run a collaborative course, applications of parallel computers that Berkeley teaches for Exceed. And what we've done is we have Moodle as a learning management system. So they use the Exceed HPC systems, but when they finish their homework, they create an archive of all of their files and upload those to the learning management system for grading. So we don't have to worry about special permissions on the main systems. So that's probably a good strategy.
At Georgia Tech, this is Trevor. I work with Memo on this instructional cluster. There was some complaining about having to upload and download and upload and download again and to the learning management system. But as Memo said, we told them we couldn't take on the risk, and they want to implement ACLs and all this crazy stuff on the file system. And
Yeah.
So, but some sort of way where they don't have to go up and down with their files would be a useful thing.
Brad posted a question about saying that most of the HPC reference materials are written by people who already understand HPC. Do any of you collaborate with a broader audience to help sort of translate HPC speak, I guess, into something that the new users can understand? I don't know if there's an answer to that question, but it's hard to change technical terms to people who have never dealt with a system like this before, I guess.
So we do it in, I guess, in an indirect way. Usually we will push the new user to go read our documentation, and if there's something that they don't understand or that they think that need to be made clearer, they can provide feedback, and we'll go back and we'll update that portion. So our documentation actually is, I guess, have been built over the process of several years. Just keep adding more information. if user wants some information about certain software, then we'll just go ahead and add that to the documentation.
Okay.
I think
Other thoughts or questions?
this is a very interesting question because in my experience, we had some students and I tried to use them for documentation. And it was very interesting to see their perspective, which was vastly different from ours. We are saturated to our content and we cannot just go outside of it clearly, but they're just looking at this with a fresh look. And we ended up not using some of that documentation, but it gave us a lot of pointers about what we need to fix in our own documentation. And unfortunately, it stopped there because we couldn't continue to hire those students. But if we have students, I would love to go back to doing that. It's a second set advice.
Question from Carl. What is the breakdown of your users between undergrad, graduate students, and researchers and faculty? Do you have some numbers or percentages that you could share?
I'm talking a lot today, but that's another question. Maybe I can answer because I reached out to a lot of departments and professors, and I collected responses with estimated number of students. And throughout 5 years, the responses were up to 2,500 graduate students and 2,750 undergrads. So it's almost like 50-50 in our experience, but it will probably change, differ from institution to institution, of course.
Okay.
Just to add to that thought real quick, I have a list of all of our users, but then that's different from what I would consider active users. So, for instance, of our 1,800 or so active research accounts, the people who are actually logging in and doing the work is overwhelmingly graduate students. And that's kind of what we would expect. And for us, I would say, second behind that would be undergraduate students who are actively working. Again, these are primarily research projects, and just because there's a larger number of them, and then followed by staff and like postdocs and research positions, and then followed well behind that by faculty who are often more in a managerial position.
Okay. Brian Gilfus, if you're there, I want to put you on the spot. If you're willing to talk about about the experience with faculty with the OSC open software.
Sure. I missed the last few minutes of the conversation, unfortunately.
Well, we were just talking. One of the questions that came up, Brian, was the new one, the batch environment and all of that, and I just thought that this might be a good intro to say something about how the faculty in Ohio are using that application. And also
well, it is definitely being widely used. So we have a product called Open On Demand that is kind of a framework that allows us to make the HPC services and resources available to clients via a web browser. You can get you can get an SSH, like a command line client or an SSH terminal via this system. It's an HTML5 system, so there's no client install required. But you can also build applications that can make desktop apps available while obfuscating some of the issues around modules and queuing systems and things like that. So you can go in and say, this is what I want in terms of resources, just like you would in a batch script. But you don't actually have to build the batch script. You just say, I want one node with the GPU for 2 hours, and hit go, and it will go off into the queue just like normal, and kind of give you a responsive screen that shows like whether your job's queued or ready, and then pop up a desktop or whatever sort of resources you've asked for or app that you've asked for. It's an open source project. It's been deployed at a number of different universities. I believe Clemson might be on the list. It's starting to get kind of long. And so we use that. That's actually very popular with both our research clients and with faculty who are teaching classes. We do also provide a little bit of training. I know there was some conversation about that earlier. We offer to come and speak for one of the lecture sections of a classroom project to say, hey, here's what we have, here's how you access the systems, here's how the command line works and the batch system works, and here's how on-demand works as well. So we found that people are starting to take us up on that request, or that offer to come and speak to the classroom environment. And on-demand, like I said, is very popular with our research clients and with our classroom projects as well.
Yeah, I'll point out that we had a webinar on on-demand a few months back, and I'll show you at the end of the thing a link to all of our past webinars. So if anyone's interested in that, you can download that and take a look at it, and then you'll have more information. Thank you, Brian. Appreciate it. Mehmet posed a question to both Notre Dame and Clemson. What's the most challenging problem that remains unresolved at this time?
For Clemson, I think the quality of the training is still, I guess, the most challenging problem. To be honest, I don't see we have a problem with the resources, and I think we are getting the account issue together. And then that leaves the issues that now we have students learning how to work with HPC from the courses. How do we ensure that they are correctly trained in doing the recommended practice in working with a shared HPC research environment, and how can we ensure, particularly for undergraduate students, is that they pick up this practices and this behavior, so that if they go into future, go to a different institution, work with HPC, they would be doing the right thing. I think that's the thing that concerns us the most. And we are actually thinking about in the term of if we train the student, and consequently future user well, hopefully that will make the job of doing supporting become easier for us. But then the next challenge with that is how do we scale up our current training models so that all of the faculty can use it. And I know that the faculty want to use our training model, but it's just that with all of the thing about curriculum and certification and requirement, we are still struggling about where to start to make the training activity become common and usable across the institutions.
Thank you. Scott, do you have anything to add to that?
Well, I don't know that I have a whole lot to add, just in terms of hitting all the high points. Internally, we like to joke that as soon as we get someone trained, they graduate. So it's kind of a constant process. You're never actually done training. One of the things that we're really trying to focus on, and this to your mentioning of Open On Demand earlier, that's a tool that we're currently investigating because we are trying to lower that barrier. We're finding that and this is going to vary from site to site, but a lot of our newer users, and if you look at total usage, comes from what we consider non-traditional HPC applications. I'm working this morning. I was working with a gentleman from the psychology department, for instance, who happens to be one of our largest total CPU hour usage groups. So just really focusing training, but also focusing on making it easier for users as well, especially when they're coming from different backgrounds in the traditional engineering and sciences.
Okay. Victor posted a question, do you provide any different tools for instructors versus students? And can instructors interact with or monitor or review student jobs? Any takers on that one?
In our case, we don't offer any different set of tools, but during the orientation for the TAs, I spend a lot of time teaching them how to keep an eye on the students for their class only. So I show them how to filter the queue status, how to filter the jobs to only focus on what their students are doing. But other than that, there are no special tools. But it's a very good point. In time, maybe we will have some.
Yeah, I know that in some cases, with classroom accounts, you'll get a student who just goes off and you, particularly if there's an allocation, uses more than their proportion for the whole class. And if this faculty isn't watching, the entire account is empty before everyone else gets to finish their jobs. I don't know if any of you run into that problem.
We try to address that proactively by putting a lot of limitations. The maximum runtime is just a couple of hours. We are also considering limiting the number of jobs per user for that cluster. But these all are, we haven't completed the policy yet. We are still working on it. That applies to data usage as well, like quotas. There are lots of questions to be answered there. So I think we're going to use this year to gain some experience and finalize our policy, and next year make another stronger start for the semester.
Great. Any other questions? While we're waiting for questions, I'm going to do a bit of an advertisement here. I'd like to talk a bit about the SIG HPC education chapter. I know this is very expensive. It's a membership is $10 a year for professionals and $5 for students. What that does is it helps us to just assemble a modest number of resources to do things like these webinars and to help build a community. And so if you go to this page, sighpceducation.acm.org, you can use this link to sign up for membership. If we look at also at our seminar series, we've had a number of presenters on a wide variety of issues, and actually on the events page, there's actually links to all of our past webinars, including the one I mentioned, Open on Demand. And so you can go back and review those if any of these are interested. And the last thing I wanted to point out is that we're a volunteer organization, professional organization, and as such, we are trying to do a number of things to promote education and high-performance computing and computational science, defined very broadly. And so we've formed a number of committees and are still looking for volunteers that are interested in these topics. And so if you go to this committees page, you can see that there are 4 major committees, and for each one we've listed our draft short and long-term goals. But one is the Education Content Committee, which has to do with training materials, which was a large part of what we talked about in this particular venue. We have another committee that's working on workshops at various conferences, so to sort of bring experiences to other professionals that are worried about training and education. The third committee is the Outreach Committee, and we're the ones who try to do these webinars and other kinds of things to help promote all of the work of the other groups. And then the final one is the Computational Science Education Committee, which is more focused on the academic mission and how you get students trained to do computational science in a very broad sense. So we're still looking for volunteers for any of these committees, if you can go to this page, or you can drop a line to officers at sigeducation@acm.org with a query about, you're interested in serving in one or another, and we will put you in touch with the leadership of that committee to get involved. And we certainly would like to get more people involved in this effort. So that's my ad for the day. So I'm going to stop sharing my screen now. Hold a second.
Steve, is there a relationship between ACM membership and SIG HPC membership, or are they?
You don't have to be a member of ACM to be a member of the chapter.
Okay, that's pretty much what I was wondering.
Yeah, so you don't have to. The ACM membership's a bit more pricey, but no, you can be a member of the chapter without being a member of ACM.
Thank you.
I think one last question came up in chat. Let me get to that. One was, have you had any requests from instructors outside of normal research HPC support? Specifically, have any unidentified needs emerged from this experience? In other words, I guess that would be what Scott was calling about non-traditional users, but maybe there are other things that have come up that were unexpected. Anybody additional want to say anything or not?
I can't think of any because we are just starting.
Okay.
But ask me this question next year.
Okay. Okay. Well, so if you're interested in, by the way, sharing this with your colleagues that weren't able to attend today, within a couple of days on the SIG HPC education page, I will have a link to the recording, and so that will be linked with the other events that we've held in the past. So you can pass that. I will send it around to various mailing lists, so that can be the discussion can be shared more widely. So with that, I think I would like to thank our panelists, Mehmet, Scott, and Lynn, for putting together your thoughts on this important topic, and for all those who attended. And I very much appreciate it. If you have any other ideas for follow-ups to this or any other webinar topics, please pass those along to me, and I'll be glad to try to recruit people to make them happen. So with that, I'm going to end the session. Thanks again to our panelists, and thanks all of you for attending.
Thank you, Steve.
Yeah, thank you, Steve.
Okay.
Thank you.